A stone, one minute. A stone tied to the end of the string 80 centimeter long is whirled in horizontal circle with a constant speed. If the stone make 14 revolutions in 25 seconds, what is the magnitude and direction of the acceleration of the stone? Let us draw a diagram. Let us draw a diagram. A stone is tied to the one end of the string. A stone is there. The length of this string is 80 centimeter or 0.8 meter. You know, centimeter can be converted to meter by dividing by 100. So the radius is, this the length of the rope is 8.8 meter. It is whirled in horizontal circle. Whirl means it is rotating, understood? Rotating. Let me draw a circle. This is a rough diagram. Remember, it is a circle, okay? The stone is moving along a circle. This side here I am holding, okay? This is the center of the circle. The stone is moving along a circle with a fixed speed. Fixed speed. The stone is moving along a circle with a fixed speed. Is it correct? With a constant speed, fixed speed. The speed is denoted by V, linear speed. It is fixed. The speed is not given. Instead of that, they says that the stone make 14 revolutions in 25 seconds. In 25 second time, let me write like this. In 25 second time, how many revolutions? 14 revolutions it make. One revolution, if the stone complete one revolution, it complete a distance. It complete a distance 2 pi r distance. Because if the stone starting from here and moving along a circle, once a complete revolution is finished, if a revolution is complete, we say that the stone travel 2 pi r distance. The perimeter of the circle is 2 pi r. So one revolution equivalent to 2 pi r distance. 14 revolution is equivalent to 14 into 2 pi r meter. One revolution equivalent to 2 pi r meter traveling. Understood? So 14 revolution equivalent to how much distance traveling? 14 into 2 pi r meter traveling in 25 second time. Is that okay? Aaron, Rakshana, Suraj, Deva, Aryan. Deva, have you understood? Please respond. All of you clear? Response is required. Okay. Devasri, I hope you have understood. So in 1 second time, how much distance? In 1 second time, how much distance? Let me divide left side and right side by 25. See, if I divide left side by 25, right side also to be divided by 25, right? I want to see what happens in 1 second time. That's why. Just divide by 25. So in 1 second time, how much distance travel by the stone? 14 into 2 into pi, you know, it is the approximate value 22 by 7. You studied in the lower classes. The approximate value pi is actually 3.14, or you may take it as 22 by 7 into radius. Radius is 0.8 meter by 25 meter. That means 1 second time the stone will travel this much distance. Is it the velocity? Is it the speed? What do you mean by speed? Speed of the stone. What is that? In 1 second time, how much distance travel by the stone? In 1 second time, how much meter travel by the stone? That is speed. Linear speed. So the right hand side is nothing but it is the speed. Speed of the stone. I can simplify it. Let me complete it. After that you can ask me doubts. 7, 14, 2 you will get. Then let me do the multiplication. 1 minute. Calculation I don't want to discuss. Calculation I don't want to discuss. 2 into 2, 4. 4 into 22 into 0.8. Divide by 25. Approximate value I am writing. I am writing only approximate value. 2 into 2, 4. 4 into 22 into 0.8 by 25. 2.8 meter per second. The speed not completed. The speed of the stone is 2.8 meter per second. Till this step, all of it clear? Till this step. Deva, Suraj, Rakshana, Aryan, everyone is clear till this step? Please respond.
Yes, sir.
Okay.
Yes, sir.
Okay. What is our question? What is our question? What is the magnitude and direction of the acceleration? Please mute your audio. Please mute your audio. In the previous class, I told you that the stone is moving along a circle, but I must apply a centripetal force. I agree that the stone is actually moving along a circle, but still, shall I apply a force towards the center? The force is necessary. Understood? Otherwise, the stone will escape from the track. Some kind of force is necessary. Every time I have to apply a force towards the center. That is said to be centripetal force. Hence, there is acceleration. Whenever there is a force, definitely there is an acceleration, which is said to be centripetal acceleration. Because F equal to ma. So whenever F is there, A is there. Understood? So there is an acceleration towards the center. That is our question. The AC, the only acceleration is towards the center. We are applying a force towards the center. Hence there is an acceleration towards the center. We studied in the previous class. AC means acceleration towards the center. Magnitude and direction both I want. We studied in the previous class V square by R. The derivation is pending, but I will discuss. Is that okay? We studied this formula. Is that okay? Please respond. Devasri, Aryan, Rakshana, Aaron.
Yes, sir.
Acceleration. V I have found 2.8. So V square will be 2.8 square by R. R is the radius, which is 0.8. Calculation you can do after the class, okay? Because if I discuss the calculation, it will take time. You can do the calculation, multiplication, division, etc. after the class. So I do it, you will get 9.8 meter per second square is the answer. So the magnitude is 9.8 meter per second square. Direction towards the center. Direction of the acceleration is towards the center. Towards the center. So all of you please write down the solution. If you are 100% clear and written, raise your hand. Let me message everyone. I think 2 students have not joined. 1 minute. Completed. Aaron. Okay, if you have finished, raise your hand. Don't forget it. If you have finished, you have to raise your hand. Aaron, Suraj, Aryan finished. Rakshana writing, right? Deva. Rakshana completed. So raise hand means that you understood the solution. Okay. Deva finished. Okay. So I discussed the important questions based on circular motion. Now in this chapter, a small theory about the vector is there. Not too much. You can, if you go through the exercise, you can see that. Not tough. A few problems based on vector is there, and there is a question, two questions, one or two questions based on this vector concept. Let me discuss the detailed study. Vector we will learn in detail later, not right now. But let me explain the basics of vector. Actually, in the I have already explained about vector, but let us have a quick recap of the vector. Some important notations are there. That notation is required. All of you please listen. Vector. By understanding vector, then only I can derive the formula centripetal force, centripetal acceleration equal to v square by r. Small knowledge about the vector is required, not in detail. What do you mean by vector? Anybody? Well, I have already explained vector, but let us have a quick recap. What do you mean by vector? Please respond.
Vector is a physical quantity which has both direction and the magnitude.
Yes. Both magnitude and direction. I will not spend more time for this, okay? Magnitude and direction. Okay, understood. So, there are certain notations. I want to introduce that notation. We have not studied that notation yet. All of you please listen. All of you please listen. This is x-axis. This is y-axis. This x-axis, y-axis together form the ground. Ground means this is the plane on which we are walking. I am walking on this ground. X-axis, y-axis together form the ground. Understood? You can imagine like this as the corner of a room. Understood? These three are the edges of the room. Okay. This is the way certain notations are there. I want to introduce it. Let this point, this axis is z-axis. X-axis, y-axis is familiar to us. X-axis, y-axis, these three are familiar to us. Okay, understood. So, all of you please listen. You are familiar with x-axis and y-axis, right? But, for example, there is a helicopter in space. There is a helicopter in the space. In that case, x-axis, y-axis, they are not sufficient to explain the position of the helicopter in the space. Understood? If the helicopter is on the ground, then okay, z is not required. If the helicopter is on the ground, okay, we can easily find the position by drawing the whole dot line like this. Suppose x coordinate is x, y coordinate is y, we write coordinate as x comma y. If the point lie on the plane ground, you studied that. But if the helicopter is a little bit higher above ground, this I want one more axis. All of you please listen, this is a new concept. It is required to answer a few problems. Suppose there is a helicopter in the space. How to explain the position? Where is it? So for that purpose, you have to draw a dot line. You have to draw a dot line to the ground. X-axis, y-axis form a ground. Understood? Just draw a perpendicular to the ground. It will be meeting at some point on the ground. And from the ground, again draw dot line towards y-axis, perpendicular, and x-axis. On x-axis, we will mark 1, 2, 3, 4, 5, etc. Right? Similarly, y-axis, we will mark 1, 2, 3, 4, 5, etc. Z-axis also, I will mark 1, 2, 3, 4, 5, etc. Suppose this distance is, position is x, I mean this distance x, and this distance is y, and the height is z. The helicopter will be at certain height above the ground, understood? Definitely some height above the ground. The height is denoted by z. The position of the helicopter mathematically represented by x comma y comma z. Before explaining vector, we must learn the position of a point in space. A new notation is explained in this chapter. Coordinates of a point in space. Coordinates of a point in space. It is a new topic. You please listen carefully. So my ultimate objective is, there is an object in the space. I want to explain the position exactly. Where is the point? So draw dot perpendicular to the ground, I mean xy plane. Draw dot line to x-axis and y-axis. The dot line meet x-axis at x, y-axis at y. Let the height be z. The position of the point is denoted as x comma y comma z. So in this way we explain the position of a point in space. All of it clear? Understood? Rakshana, Suraj, Deva, Aryan, please respond. Rakshana understood. Aryan understood. So in this way, okay, so x, y, z, you understood the meaning of each letters, okay? So coming back to vectors. Okay, let me introduce a new terms. Let me introduce a new terms. All of you please listen. The direction of x-axis. Can I define a vector in the direction of x-axis having length 1 unit? What is vector? Vector is a physical quantity having both magnitude and direction. Vector is a physical quantity, for example displacement, having magnitude and direction. Somebody travels just 1 meter in the positive direction of x-axis. Is it a vector quantity? Yes, because he has got a displacement in this direction. The magnitude is 1. Somebody traveled just 1 unit towards x direction, then it is a vector quantity. That vector quantity is denoted by the symbol I. First time you are listening this, memorize that I is the vector. I is a vector having magnitude 1 unit, direction positive direction of x-axis. So I define a new vector I. So somebody has got a displacement I. What does it mean? That means that he has traveled 1 unit in the x direction. That's the meaning. So let me define another vector. Somebody has traveled 1 unit in the y direction, just 1 unit. Is it a vector quantity? Yes. Magnitude is 1 unit, direction towards y-axis. This vector quantity is denoted by J. And the third one, somebody, for example, a helicopter. A helicopter just move upward. Helicopter move upward, just 1 unit move upward. Is it a vector quantity? Yes. Magnitude 1 unit, direction upward, z direction. It is denoted by K. Above K we use a letter like this. Don't worry about that. So there are 3 standard vectors. These 3 are also said to be unit vectors because their magnitude is 1. So there are 3 standard unit vectors. There are 3 standard unit means magnitude is 1. I cap, I, J and K. The direction I have already explained. 2 things I explained right now. The position of a point I explained, and the 3 vectors I defined, standard vectors I, J and K. All of you please draw this diagram. If you are 100% clear and drawn this figure, then raise your hand. These are required in numericals, okay? Rakshana, Suresh, Deva, understood. Aaron, Adi, Aryan, everyone is okay. Now, let me discuss one important point. Listen. This diagram is not required now, but let me draw it again. X-axis, Y-axis, Z-axis. This is said to be origin. Suppose there is a point, a helicopter initially at A. A helicopter initially at A. Please remove your right hand. A will have a position, say x1, y1, z1. I explained the meaning of each letters. I discuss about the meaning of each letters. A helicopter, let me talk about helicopter, then only you can understand. The helicopter in space having position x1, y1, z1. Along a straight line, it has moved to another location, say B, along a line, with the new position is x2, y2, z2. Has it got a displacement? Yes. The helicopter has got a displacement. The displacement vector of the helicopter denoted by AB. Vector AB. It is not like this. The displacement of the helicopter is denoted by vector AB. It is written as. Let me write the formula. After that, I will explain the meaning of each terms. Let me write the formula without any derivation. After writing it, I will explain the meaning of each letter. All of you please listen. The displacement vector AB is defined as x2 minus x1i plus y2 minus, I will discuss the meaning of each term. Listen carefully. Plus z2 minus z1k. What does it actually means? The actual meaning I will tell you. What is this I? I is this one. 1 unit motion along x direction. J is 1 unit motion along y direction. K is 1 unit motion along z direction. So a helicopter has got a vector, displacement vector this much. What is the coefficient of I actually means? The coefficient of I is x2 minus x1. What does it actually means? Actually means that as the helicopter moving from A to B in x direction, it cover this much distance. In x direction, it cover this much distance. For example, suppose this x direction stands for say what is that? South. For example, south. Y direction stands for say east. Let me give some name. If the helicopter lying in the space moving from one location to another location, will it cover some displacement along south direction, some displacement along east direction? Will it happens? Yes. It is moving in some direction in space. It will cover some distance along south direction. Understood? It will cover some distance in east direction, and in some distance along height along z direction. So x2 minus x1 means that if the name is like this, south and east, x2 minus x1 I means that as the helicopter moving from A to B, it cover x2 minus x1 distance travel along I direction. In south direction, it cover this much distance. In j direction, in east direction, it moved y2 minus y1 distance. In k direction, it is very easy to understand. In k direction, it travels z2 minus z1. Meaning that k direction means height. The height is increased by z2 minus z1 unit. K direction means The height is increased. As the helicopter move like this, height is increased by z2 minus z1 unit. So that is the meaning of that. Okay. So you just understand. Let me write here. x2 minus x1 stands for the distance, the displacement along I direction. For example, south direction, the helicopter cover this much distance. y2 minus y1, coefficient of j stands for the displacement along j direction. J means east direction, for example. Coefficient of k stands for the displacement of the helicopter along k direction, meaning that height is increased by this much z2 minus z1 unit. All of you please write down. And one more thing. Let me write one more formula. After that you can ask me doubt. Okay. So what is the benefit in writing IJK format? So we get a good clarity about the direction of the helicopter. East direction this much, south direction this much. If I get the information separately, we get a good clarity about the direction of the helicopter. Suppose we are not interested in I direction, J direction, K direction. I am not interested in separately. I want only the net distance traveled by the helicopter. I am interested only this much. What is the net displacement covered by the helicopter? I don't need how much in I direction, how much in J direction. I am not interested. Suppose I want what is the displacement between initial and final. Then that is said to be magnitude of the displacement, denoted like this. Magnitude of the displacement, the distance between the initial and final position. Let us learn without any derivation. It is not required in physics and also not required in maths also. So don't need to spend time for that. Okay, derivation is not needed. So the distance between A and B is the magnitude of the displacement of the helicopter. It is given by, just memorize this formula, very important formula. Magnitude of the displacement is equal to, memorize like this. I will give you example after this. Coefficient of I square plus coefficient of j square plus coefficient of k square. What is that coefficient of I? This one is coefficient of I. This one is coefficient of j. And this one is coefficient of k. All of you please write down. And I will not explain these IJK notations later. Okay, it is required in the other chapter also, work done. In the chapter work done, we require these symbols, IJK notations. I will not teach it again. Okay, all of you please write down. If you have finished and understood, raise your hand. Suraj Deva understood. And if you have any doubt, please ask me your doubt. Okay. This theory is required in the next chapter, 5th chapter, work done. Okay, work, energy and power. Most of the question contains IJK representation. So you understood. Rakshana, Suraj, Deva understood. Aaron understood. Aryan clear. Let me give you a simple example, then only you can understand it. Simple example. Initial position. I mean, for example, a helicopter. A initial position 154. I explained about the meaning of this x comma y comma z. The initial position of a body moving along a straight line and final position. Say B 3 8 10. Question is find vector AB. I mean east direction how much, south direction how much, height how much individually. I mean IJK format. Also I want the magnitude of the displacement. I want. It's a simple question. You can understand. You will understand this formula. That's why. AB. What is the method of finding AB? Look at this formula, you can understand that. AB is equal to final minus starting. Is it correct? Final minus starting. That's why x2 minus x1 I, y2 minus y1 j, z2 minus z1 k. So final minus initial. So x2 minus x1 will be 3 minus 1 I. Correct. x2 minus x1 3 minus 1 I. y2 minus y1 final minus starting 8 minus 5 j, then z2 minus z1. Correct. z2 minus z1. So 10 minus 4 k. So AB equal to the displacement vector is equal to 2I plus 3j plus 6k. Meaning that if the helicopter move like this, it cover 2 meter in the I direction. It will cover 3 meter along j direction. The height of the helicopter is increased by 6 meter. Understood? Okay. And the magnitude of AB, meaning that the distance between initial and final, the magnitude of the displacement vector is given by root of formula coefficient of I square plus coefficient of j square plus coefficient of k square. Coefficient of I square plus coefficient of j square plus coefficient of k square. 4 plus 9 plus 36. It is 7 meter. The helicopter will have a net displacement 7 meter. All of you please write down. If you are 100% clear, raise your hand. Rakshana, Suraj, Aryan understood. Aaron understood. Devasri, if you have any doubt, please ask me.
Yes, sir.
Understood. Completed.
Yes, sir.
Okay. Completed. Next is mute your audio. Addition of two vectors. It is required. Okay, there are plenty of questions. Addition of, in the exercise there are questions. Addition of two vectors. Actually I discussed, but I think a few students have not attended that class. So let us have a quick recap. Addition of two vectors. Suppose initially I travel a displacement. I got a displacement a unit. I mean vector quantity. Displacement is a vector quantity. Initially I got this much displacement and I reached this point. and I travel, I got another displacement, say B. This is my final position. This is my initial position. This is my initial position. Initially, I got a displacement A in some particular direction, for example, east direction. And after that, I got another displacement, maybe say something like 30 degree with the east direction, something like that. I got another displacement. What is my net displacement? Not net distance. I'm not talking about net distance. Net displacement is obtained by joining the initial position. Is it my initial position? Is it my final position? Just joining initial and final position. This is defined as the net displacement. It is denoted by A plus B. Initially I got the displacement A. Later I got another displacement B. What is my net displacement? Denoted by A plus B. So to find two vectors, first A is drawn, then B is drawn. Just complete a triangle. Just complete a triangle means starting joining initial and final point. You will get A plus B. It is required. Okay, so this is very important. So in this way we can add geometrically. But if the vectors are given in terms of ijk, this diagram is not required. This is the geometrical method of vector addition. Geometrical method. But if the vectors are given in terms of ijk, this diagram is not required. I mean, for example, say for example A equal to say I plus 2j plus 3k meter. Just like a helicopter movement. Initially helicopter has got a displacement A plus 2i plus 3k, 2j plus 3k. Later helicopter got another displacement, something like, say, let me write some example, 2i plus 5j plus 9k. Initially helicopter moving in space, this much displacement. Later helicopter has got this much displacement. What is the net displacement of the helicopter? Joining initial and final. So in that case, if the A and B are given in terms of ijk, that diagram is not required. The net displacement is obtained by simply adding them. Addition is very simple. Just add the similar terms, like I plus 2i. It is 3i. 2j plus 5j, 7j. 3k plus 9k, 12k. Like that. So if vectors are given in terms of ijk, in that case diagram is not required. You simply add them. But if displacements are in the, I mean ijk are not mentioned. For example, I travel 10 meter in the east direction. Later I travel 20 meter in the northeast direction, 20 meter. What is my net displacement? In that case the diagram is required. This length will be the my net displacement. You understood? So this is actually said to be triangular method of vector addition. Definition is not required. You just write whatever I have written, you just copy it. Okay. If you have finished, raise your hand. Done. If you have any doubt, please ask me. Actually, I discussed the vector addition. All these topics are there in this chapter. Everyone is clear? Aaron, everyone is clear. Okay. So the vector addition is clear. Then multiplication of a vector. By a scalar. These are required. There are questions. Multiplication of a vector by a scalar. Suppose a person has got this much displacement, magnitude and direction is there. A person has got this much displacement. Another person has got twice the distance traveled by this person. There is another person who travel 2 times the distance traveled by this person, moving in the same direction. Then the vector look like this. Understood? Another person travel twice the distance traveled by the first person, but in the same direction. Then the displacement vector of the second person denoted by 2 times a. 2 times a means 2 times the displacement covered by the first person, but direction remains the same. Then what do you mean by 3 times a then? 3 times a means 3 times the distance covered by the first person. 3 times. But the direction remains the same. So if you multiply by a scalar quantity, I mean positive number with a vector, that much magnitude is increased, but the direction same. But this, remember by looking at this diagram, and if you multiply by a negative number, for example minus 2a, the negative number means the opposite direction. The negative sign indicate that the opposite direction. Minus 2a means 2 times the distance of a, but negative sign indicate opposite direction. Remember, negative sign indicate opposite direction. Minus 3a means 3 times the distance covered by first person, but negative sign indicate the opposite direction. This is the geometrical method of finding the multiplication of a vector by a scalar. Geometrical method. All of it clear? I have already discussed this. Do you remember? Rakshana, Suraj, Deva, Aryan. Is that okay? Clear?
Yes, sir.
But if the vectors are given in terms of, listen, if the vectors are given in terms of ijk, this kind of diagram is not required. If the vectors are given in terms of ijk, for example a equal to like 2i plus 3j plus 6k, this is a helicopter vector of displacement vector of a helicopter. Another helicopter moving 2 times the displacement traveled by the first helicopter in the same direction. In that case, the diagram is not required. 2 times a is obtained by 2 times a. Understood? You just write the step. Without drawing any diagram, we can find it. 2 times a, right? Just open the bracket. 2 into 2, 4i. 2 into 3, 6j. 2 into 6, 12k. So 2 methods I discussed. Multiplication of a vector by a scalar. First one is geometrically, how to find 2a, 3a, 4a like that. The second is algebraically. Algebraically means diagram is not given. A vector is in terms of ijk given. So just it's very simple. Second method is very simple. If the vector is given in terms of ijk, it is very easy to find 2a, 3a like that. So all of you please write down. If you are 100% clear, raise your hand. Rakshana, Suraj, understood. Aryan, okay, clear. Aaron, understood.
Yes, sir.
Okay. Then vector subtraction is there. I will explain the geometrical meaning. Vector subtraction is there. It is very important actually. Vector subtraction. Let me discuss that one also. I think next class this chapter will be over. Okay. 1 minute. So operations on vectors means addition I discussed, multiplication of a vector by a scalar I discussed, then subtraction, vector subtraction, subtraction of two vectors. It is important, especially for finding the change in displacement, change in velocity, change in displacement, like that. We require subtraction. All of you please listen. All of you please listen. Suppose we have a vector like this. Let me draw a triangle. We have another vector like this. Another one. Okay. Let me give some name for each vertices A, B, C. By triangle law we studied. Initially I got the displacement AB plus. Later I got another displacement BC. The net displacement will be AC. I have already discussed the vector addition geometrically. AB plus BC, in the what is the net displacement? AC. You agree with me? This one is clear to you? Correct? Please respond. Is that okay? Whatever I have written, is that okay? Clear?
Yes, sir.
Okay. Now I am defining subtraction. Let me define subtraction in the normal way. Just like I will tell you. I am going to define subtraction in this way, normal way. Like I am taking this AB to the other side. In this way I am defining subtraction. In this way. For example, in the normal addition, what we do, if I take any term to the other side, it becomes negative, right? If I take 3 to the other side, it becomes minus 3. If I take 7 to the other side, it becomes minus 7. In this way I am defining vector subtraction. This is the way I am defining vector subtraction. So what is BC then? BC will be AC is already there in the right side. AB is go to other side. AC minus AB. BC equal to AC minus AB. So let me give some name. Let me give some name for AC. Can I give some name for AC? Let me give let me give some name. Say for example P. I don't want to use ABC. AC I am giving a name for AC, say P. AB, let me give some name Q. What is BC then? What is BC? BC is equal to AC I have given a name P. AB I have given a name Q. So BC equal to P minus Q. I will repeat, it is a very simple maths. So I got BC equal to P minus Q. BC equal to P minus Q. How to understand that? So from this example, what is our conclusion then? What is our conclusion? What is the meaning of P minus Q then? Meaning of P minus Q is to find the P minus Q. See, P minus Q I will tell you. P minus Q is nothing but P is the vector reaching the final point. P is the vector reaching at the final point. Q is the vector reaching at the initial point. From the common point. Just understand, okay, there is nothing to worry. So P minus Q is given by P stands for the vector ending at the final point. Q is the vector ending in the initial point. Then this will be P minus Q. Just understand that. Even if you don't remember this diagram, don't worry. Vector subtraction is defined in this way. One vector to be taken to the other side, it becomes minus. Actually, if you don't remember this diagram, don't worry, leave it. You understood how we define the subtraction, you understood. If a vector is taken to the other side, it becomes minus. In that way we define subtraction. That's all. Okay. All of you please write down. Okay. All of you please write down. You need not worry about the diagram, okay? I will discuss problems from textbook. The vector subtraction we obtain when one vector is taken to the other side, it becomes minus. In that way we get subtraction of two vector. Understood? If you are okay, 100% clear, raise your hand. And if the vectors are given in terms of I, j, k, we don't need any diagram. If the vectors are given in terms of I, j, k, do we need any diagram? No, not needed. P is given to us, Q is given to us, like this. How will you find P minus Q? Do we need to draw the diagram? Not required. You simply subtract them, just like a normal way. Subtract the similar terms. 5i minus 2i, 3i. 5i minus 2i, 3i. 6j minus 4j, 2j. 11k minus 3k, 8k. If the vectors are given in terms of I, j, k, addition, subtraction, multiplication by scalar, everything is very simple. Okay, geometrically this is the meaning of difference of two vector. Okay, all of you please write down. If you are okay, 100% clear, raise your hand. I will discuss the problem related to this theory in the next class. There are questions in the exercise. I will discuss in the next class tomorrow. If you have written, then understood, then you can leave the meeting. The remaining part I will discuss in the next class. Okay. Almost finished. A few problems related to vectors is remaining and one derivation is remaining. That's all. Okay.